All right. So, um, many of you are here today. That's good. Um, let me just tell you about our schedule. And anybody's hearing this on the recording will hear this too. So our first quiz, I've been trying to extend the time as much as I can for starting, things that we have to grade. And so I've extended as far as I can. So Thursday is going to be quiz number 1. It will cover the first 4 chapters, which I'm finishing up today, this morning. I'm finishing up chapter 4. Um, and then we're covering chapter 5 this week, which is a part of chapter 5 today, and then continuation of chapter 5 on Thursday. But anyway, we're completing the chapter 4 today, and then our quiz on Thursday, which, by the way, will happen after I've completed my presentation on chapter 5. It'll happen towards the end of the period. I'm scheduled for 20 minutes. We'll cover the first 4 chapters, all right? And it's mostly definitions. It will not cover chapter 5. Now, there are 9 quizzes scheduled for the semester. So it's the fact that I've waited so long to do the first quiz means that the second quiz will be following up pretty quickly, which means next Tuesday would be quiz number 2, which will cover chapter 5. So typically, not all the time, but typically a quiz covers what we covered the previous week. But this time it'll be chapter 5 instead of nothing about chapter 4 in quiz number 2. Also, next Tuesday, we will have a review for our first test. And the first test covers all 5 chapters. And during that time, I'll explain exactly what the test will look like and give you some idea about that. And so, and it'll cover all 5 chapters. There'll be, hardly anything with calculations. There might be, I think we had covered something with a calculation with the margin of error. So that's a possible calculation that may show up on our first test, but mostly it's just concepts and definitions type of thing. But I'll explain more about that on next Tuesday, which will be, again, quiz number 2 and a review for test 1. So test number 1 will be a week from this coming Thursday. All right. Let's see, that makes it the 18th, right? 18th of February would be test number 1. So I try to have a test every month. So there'll be one February test, there'll be a March test, and there'll be an April test. And it's all on the schedule. I'll try to keep to the schedules very tightly as far as the tests are concerned. And then there's a final exam also. But also, as I said earlier, there are 9 quizzes this semester, 9 of them. So for some reason you don't do well on one of them, there's opportunities to make it up pretty easily because there's 9 of them. All right, any questions about any of that? And the quizzes are basically fill in the blank quizzes, or mostly like that. There's a couple that are near the end of the semester where we might have a question where you make it's a pull down box and you just choose the answer from the pull down box, but mostly fill in the blank. Try to, when you look up the answers, try to write down the answers correctly. That means spelling. Make sure you spell things correctly. I try to anticipate errors that people tend to make when I give the possible answers for a question, but I can't anticipate all of them. And also, please don't repeat words that are in the sentences. People tend to do that. I don't know why, but they don't read the complete sentence when they fill in the blank, and they repeat a word that's already in the sentence. Don't do that. I can't anticipate that. All right. So just take your time and you should again, to prepare for this, for the quizzes and for the tests, you need to read the book. Have the book available. Hopefully all of you have it by now. If you don't, you should go and get the ebook at this point. All right, get the ebook. You go to cengage.com, type in, if there's a student button that you click, and then type in the name of the book or the author's name, and make sure it's the 4th edition of Seeing Through Statistics, and buy it online as an ebook. because at this point you need to have it. We're in our third week of the course, and I know that the bookstore has been not good about sending out the books on time. I don't know why that's the case. Maybe you just don't have enough staff or something. But at this point, you really do need the book. So if worst comes to worst, get the ebook online. All right. That's all I can say about that. For the first quiz, if for some reason you can't afford it, the ebook and the book hopefully will come in the next couple of days, then the best that you can do is look at the PowerPoint slides that are available on Canvas. I posted all of them. So that will be you would have to review the PowerPoint slides for the first quiz. But certainly for the next 8 quizzes after that, you definitely need the textbook, and you need to read the textbook. Please read it. I know some people don't read textbooks. This course, it's pretty much the course is to read the textbook. So it's very important that you read it. It is a readable textbook. It's not like a typical statistics textbook, which is hard to read. So please read it, and again, come to the classes like you've been doing. Obviously, you're here today, and then ask me questions if you have any issues. All right, and that's about all I can say about that. So recording is started. I'm going to now share the screen, and I'm going to go to the last section of chapter 4. So I'll share this with you. All right. So now this is a little bit of a repeat what we did last time, but I do want to review with you the types of random sampling that we have when we have sampling, when we collect the participants for our surveys. And the first one that I talked about last time was simple random sampling. And this is where, now, first of all types of sampling plans which use probability. Now, what's probability mean? Random. The word random, word probability mean the same thing. It means that we're not picking people based on convenience. We're not picking people based on them being volunteers. We have a way of numbering everyone in the population, and then we randomly select using some random numbering system. They're probably with a computer. We're going to select people randomly to be in our sample. Now, probability sampling plans in general means that everyone in the population has an equal chance or has a specified chance of making it into the sample. All right, I shouldn't say equal chance because sometimes it is unequal, but everyone has a specified chance of making the sample. Now, simple random sample is the case where we're selecting people randomly from the population, and we get our sample that way. And here's the definition of simple random sample. It's where the sample that we choose has an equal probability of being chosen from all possible samples of that same size, right? Now, what does the size mean for a sample? It means the number of people in the sample or number of things in the sample. That's what it means. So if we have 100 people in our survey and we chose 100 people randomly from a population, the probability of choosing that particular sample would be the same as choosing any other sample of size 100 from that population. So if all of you, every single one of you, chose your own sample of 100 randomly, they would all look differently, probably. They all have different people in them. Maybe there would be some people that would be the same, but most of the people would be different. But each one of your samples would have an equal chance of being chosen, okay? And that's what's called a simple random sample. Every person in the population. So what do you need to do a simple random sample? Again, you need a population. Obviously, you need to have a list of them, and the list should be numbered. All right, so you have to have some list which is numbered, and then you have some way of selecting random numbers, so that once you select these random numbers, whoever is assigned that number in the population gets chosen for the sample. All right, so that is called a simple random sample. Now, once again, this is a slide I showed to you last time, how to sample from your class. So suppose there's 200 people, 200 students in your class, and you want to take a random sample of 25 students. First of all, what is the margin of error formula? It's 1 divided by the square root of the size of the sample, 25 in this case. So we calculate that. 1 divided by the square root of 25 is 1 divided by 5. That's equal to 0.2. Use your calculator. And anytime you want to convert decimal into a percentage, you multiply it by 100. So that's 20% is your margin of error. All right. So what do? Step number 1, you get your list of students, all 200 of them, and you assign a number to each one of the 200 students. Number 2, obtain 25 random numbers between 1 and 200. Each number should be between 1 and 200, and you should obtain 25 random numbers through some sort of system, either putting numbers from 1 to 200 into a box, mixing them up and drawing out 25 one at a time, or a better system would be using a computer or a calculator to come up with your 25 random numbers. And those people who have those random numbers will be the ones selected for the sample. All right. And then, of course, number 3, you locate and interview those people on your list whose numbers were selected. All right. Now, this is where we stopped last time. There are other types of random sampling. Now, you need to know these definitions. Okay, I have to tell you, this is part of the course. You need to know these definitions. Also for not only quiz number 1, which is on Thursday, but also for test number 1, which is next Thursday. All right, you need to know these definitions to be able to recognize them when you see them. All right, you don't have to know much about them other than that. You just have to know the definition and be able to recognize in a very simple situation, how to recognize what they are. All right.
Is this for quiz? Sorry, Professor, is this for quiz? The
yes.
one coming up, those
yes.
definitions,
yes.
gotta know that.
Yes.
All right.
Yes. Stratified random sampling. Now, the word strata means group. All right. S-T-R-A-T-A means group. Now, if your population can naturally be divided into groups, and they're non-overlapping. What does that mean? It means there's people, if a person in the population can only be in one group, all right? They're in a group, but they can only be in one group. They can't be in more than one group, all right? So that means that's what we mean by non-overlapping. They don't overlap at all, but they cover the entire population. So we divide the population into groups or strata. And then what we're going to do is take a simple random sample inside each of those groups. So instead of taking a simple random sample from the whole population, as I showed in the previous example with the 200 students, we're going to break the population into groups and do a simple random sample within each group. And then we combine them all into our overall sample. Now, what's the advantage of doing this? Why would you want to do this? Well, let me give you an example of this, and then I'll go over the list here. Suppose you had suppose you were an educational researcher, all right? And you were interested in a new reading program for high schools, all right? And suppose in your school district, there are 4 high schools. 3 of them are large, 500 to 1,000 students each. And suppose there was one high school that is a small one. It's in a remote area of where you live, and it only has, let's say, 50 students. All right. So you have 3 larger high schools, about the same size, and then you have this small high school of only 50 students. Well, you want to make sure that every school, all 4 schools, are participating in this survey or experiment, whatever it might be, whatever study you're doing about this new reading program. And you want students from all 4 schools to be in the study. Now, if you did a simple random sample for the entire, hold on a second. for the entire school district, all the students, there is a possibility that that small school would not be represented because it's so small. It's possible that you only get, if you randomly select, it's possible you only get students from the 3 larger schools because they just happen to have more students, and it's easier for those schools to be represented in your sample. So to guarantee that all 4 schools are in your sample, you do a stratified random sample. That is, you break the population of students into 4 groups. That's the 4 schools. So that'll be your strata. And then you do a simple random sample within each of those schools. And that way, you know, you're guaranteed that that small school will have at least some students in your sample. Right? So that's the advantage of doing it. All right. You're guaranteeing that all groups are represented in your sample. What's the advantage besides that? Well, what's nice about it is that whatever you're measuring, you're going to have estimates for each of those groups. So not only will you have an overall estimate for the entire sample, but you're also going to have individual estimates for those groups, for those strata. So if you were measuring, let's say, if you had some measure for improved reading ability for the reading program that you're trying to find out about, all right? Improved reading ability is what you're measuring. Not only will you have that, a measure of that for the entire sample, but you're going to have that also for each individual school. And if you're an educator, that's really important to know, not just for the whole district, but also for each school, all right? So this is a big advantage of stratified random sampling, right? You're also going to get more accurate estimates of population values just because you're dealing with these homogeneous groups, which are these schools, all right? So it's good. Also, if these schools are geographically separated, which they would be, right? They may not be right next to each other. They're probably going to be some distance from each other. It may be cheaper as a researcher to sample them separately, as opposed to trying to go from one school to the next, trying to do a simple random sample. All right. So those are big advantages for doing a stratified random sample. All right. So once again, you break your population up into groups, and then within each group, you do a simple random sample. All right. Any questions about that? I think it's all right. Now here's another one. This one is called cluster sampling. Cluster sampling. Now people tend to mix this up with the stratified sampling, so you have to listen to this closely. We are also, in this type of sampling, dividing the population into these groups, non-overlapping again, all right, groups. We call them, in this case, clusters as opposed to strata. Now, what are we doing in this case? We break the population into groups, and then we do the following. We take a random sample of the groups of the clusters. So suppose, we divide the population into 10 groups. All right, there's 10 groups. And suppose we randomly select 3 of the groups to be in our sample. That's what a cluster sample is. We don't have every group that's in the sample, only a random, a smaller sample of these groups of clusters. And then once we have those random sample of clusters, we just interview everybody that's in those clusters, in those groups. All right. Now, why would we want to do this? Suppose you work for the U.S. government. Okay, you work for the U.S. government, and you want to interview adults in a city. All right, but you don't have a list of the adults who live in the city. There's no list of them. What you do have, however, is a list of households. All right, in different geographical areas, a list of households. Now, households consist of a group of people, right? It could be many people in a household. So the households become the clusters. Or even a better choice would be neighborhoods. Suppose you only have a list of neighborhoods, all right? That's all you have, list of neighborhoods. And you want to do sampling within the neighborhood. Well, you randomly select neighborhoods, and then you interview everybody inside each of those neighborhoods that you've selected. So here's the advantage. You only need a list of the clusters or groups in case you don't have the list of the people that you want to interview, all right? So here's an example. You want to sample students living in a dorm at a college. Now the college has 30 dorms. Each dorm has 6 floors. That means there's 180 floors, all right, altogether. Now your job is to interview students, but the only thing you know is a list of floors. That's all, because each dorm has 6 floors. There's 180 floors. And what do? You take a random sample of floors, all right, of floors. So out of 180 floors of dorms that exist on the college, maybe you're going to select 20 of them and then interview everybody on each of those 20 floors. So this is called cluster sampling. Again, you divide the population into groups. This time we call them clusters, but now we're taking a simple random sample of clusters because that's all we have. And then we interview everyone inside those selected clusters. Does anybody have any questions about cluster sampling and how it's different from stratified sampling? All right. Now remember, you have the book will be an open book when you take your quizzes and tests. You just have to read through it and just get it really clear in your mind, the difference between the two, because you do need to know that difference. All right. All right. Now, here's another type of sampling. This is called systematic sampling. All right, suppose we just have a list of people. All right, a complete list. That's all we have. Somebody gives us a list of names. Now, when we used to have telephone books, remember, they still have them online, but remember the old-fashioned telephone books you would get, the paper ones, the books, thick ones, and they would have a list of names alphabetized, right? Well, suppose there's 5,000 names in your telephone book, and you want to take a sample of 100 of them. Now, would you just pick the first 100 names? That wouldn't be random, would it? Because what you're picking are the A's and the B's, maybe, or the C's. You're not picking anybody with names that start with letters like with T's and S's and names like that. So you're missing. You're not going to have a random sample doing that. So what do? Well, one way of doing this is called systematic sampling. All right. And there's some math involved with this, which you don't need to know, by the way. You don't need to know the formula for doing this. There is a formula. It's not hard to understand, but again, we're not going to deal with that in this course. What you will need to understand is that you need to have some sort of system of picking a random number. There's some random number that you're going to pick, just one, and it typically will be from 1 to some number like 50 or 30 or something like that. And you just ask the computer to pick a random number. Once you have that random number, that is the first person on the list that you will pick. So for example, 5,000 names, you want to have a sample of 100, all right? Now, one thing you could do, and this is the math that's behind this, by the way, is you can divide the list into 100 consecutive segments of 50. Now, where do they come up with 50? 5,000 divided by 100 is 50. That's how they came up with it, all right? So if you need 100 people and you have 5,000, just divide 100 into 5,000 and you get 50. So what you're basically doing is you're going to have 100 consecutive segments of 50, all right? And then you're randomly selecting a starting point in the first 50 names. So in this particular example, you're going to ask the computer to pick a number from 1 to 50. Suppose it picks 8, all right? Suppose it picks 8. So the 8th person on the list is going to be the first person selected. And then every 50 names after that will be the next people to be selected, all right? And that's how it works. So if the 8th person is picked, Then the 50th person after that is number 58. The 50th person after that is number 108. You just keep adding 50 until you get your sample of 100. So this is called systematic sampling. You only have to use random sampling for the very first person that you select, and then you have this maybe the 50th person after that to be selected. It doesn't have to be 50, by the way. The number could be any number here. If you had 10,000 names and you wanted a sample of 100, then it would have been 100 consecutive segments of 100, and therefore the random number would be from 1 to 100 that you would select, and then every 100th after that. So the problem that is, well, it's not going to be a math problem, I'm telling you, but you have to recognize it as systematic sampling. It has to be something like this, where you're randomly selecting the first person, and then you have systematically choosing the 30th person or the 50th person after that, something like that. If you see that type of sampling, that's called systematic sampling.
Wait,
right?
I have a question just to
Yeah.
like clarify.
Yeah,
So like I choose like a random, like say it's 100 people, I choose a random number like within the 100 and I want like a sample of 50. So anything after that number, is that what you're saying? Like,
well, with this example here, if you have 5,000 names, right? Doesn't it make sense, and you want to run a sample of 100, doesn't it make sense that you would have 100 segments of those 5,000 names? Wouldn't it make sense? In other words, every 100th person you would select, every 50th person you would end up selecting somebody. Wouldn't that sort of make sense to you? If you have 5,000 people and you want 100 people from it, and you want it, systematically chosen, wouldn't you just select every 50th person?
oh, okay, so that's what you're doing.
Yeah,
So
but
every
here's the difference from what I just said. If you were just doing that and just picking every 50th person, that wouldn't be random sampling. That would be systematic, but it would be systematic non-random sampling if you did that. Where the randomness comes in is you're randomly selecting the first person. So remember, in this case here, you have 100 segments of 50 people each. So there's the first 50 people, the second 50 people, and all the way up to the 150 people. All right, you get that idea. What's different about this type of random sampling is that the first person that you're choosing is not going to be number 50 necessarily. You're going to ask the computer to choose a number from 1 to 50. See what I'm saying? For the first 50, you can.
Okay, so like say, okay, so if there's 100 groups and if there's 100 groups of 50,
yeah,
and like say you choose number 2, then you do 2 of each group.
Yes, and then it would be the second in each group. And literally what that means is the first person's going to be number 2, the second person's going to be number 52, right? Because that's the second person in the second group.
Yeah,
So-
okay, that makes sense.
102, and yeah, that's you actually said it very clearly. That's very good. So,
All right, so it wouldn't be like, so it would be the second person in every group, but not like 2 people from every group.
no,
So the
Only
second
one-
person from every
only
group.
one person from each group. It just
Okay.
happens to be when you randomly select that first person, it tells you what position in each group you would be selecting. So your description is very good. So if you happen to select, if you randomly selected the number 2 from 1 to 50, that's the number you end up randomly selecting, then it's the second person in each group. And the way to find that number is the first person is going to be 2, and then you add 50 to that. The second person is going to be number 52, which is the second person in group 2. Then add 50 to it again, that's 102. That's the second person in group number 3. Like that, you keep adding 50 until you get all 100 people. So your description is very good. I like the way you described it. All right, is everybody clear how this works? And again, the math behind it, don't worry about it, because whatever I give you as an example, it'll be sort of built into the way it's written. So you don't have to do the math, but you have to recognize what you see as systematic that is systematic. All right. Another place where systematic sample is used is in a factory. If you wanted to do something like, let's say you were creating these boxes of your product coming off an assembly line, and you wanted to check not every box, but every 20th box or 30th box or something like that for defects. In other words, you wanted to open up the box, take the product out, and do some testing on the product to make sure it's not defective. You would do systematic sampling. You would do the same type of sampling. You would randomly select the first box, and then every maybe 20th or 30th box after that, you would just pull off the assembly line and check for defects. So that's another reason you might want to use systematic sampling. All right, any questions? So those
Yeah,
three
can
types
you,
of- yeah, go ahead.
yeah, Professor, so this is Anika Pitts. So she used the number 2.
No,
So
that's
you
what
do,
go ahead,
yeah,
I'm sorry.
yeah, I'm gonna go with her example. So she chose number 2. So you do the second person and then count 50 in the next group.
52 would be the next one. You add
Okay,
50.
so keep counting 50 spaces and then whatever number you chose.
Yeah, that's it.
All right, okay.
That's how it works. And it makes sense, doesn't it? The randomness comes in the very first one that you choose because you're randomly selecting the 2. The
Right,
computer,
right.
Aaliyah could have chosen 2 when she randomly selects it. And Anika, you could have ended up asking the computer and it chooses number 43. Right?
Like 4,
So then the
right.
43rd
So it
one
would
in each
count
group gets checked.
50 and plus 4.
Well,
Okay.
if you chose 43, if your computer chooses 43 as a random number for the first 50, then it's the 43rd person chosen, and then you add 50 to that, that would be 93, be the second person. Add 50 to that, you would get 100 and what is that? 143 is the next one, like that. All right.
Okay.
So the randomness comes in the very first number, and you get then. If there's 50 of these segments, you just keep adding 50 until you get all 100 people that'll be in your survey. All right, and I think there's it might be another example or 2 in your book. That's why you read the book, because you see other examples in there. All right, any questions about that? So that's systematic sampling. Pretty different then from the other 2, right? From the other 3, because we've had 3 others, right? We had simple random sampling, we've had stratified sampling, we had cluster sampling. Systematic sampling is definitely much different than the other 3. This slide here just tells you a procedure that some organizations that do sampling use. It's called random digit dialing. And that's why you may get a phone call sometimes and they say, we're going to do a sample. You've been chosen for a sample. Well, that's because the person that was selected, was, it's a simple random sample, but it was done through this technology called random digit dialing. All right. And it explains here how it works, but it's really simple random sampling. But what are they simple random sampling of? Households. All right, not individuals, because in the United States, you typically don't have lists of individuals. You have lists of households. So simple random sampling, sometimes it's done through this thing called random digit dialing. All right, and it's a way of doing it through a computer. Just know the term, that's all. Just know in general what it means. It's just a procedure for doing simple random sampling of households. Well, not all I'm going to say about that one. Here's an example of doing a sample, and just this shows you the complexity sometimes of doing sampling, because it's very complicated. Because of what? Because you have people chosen, and then when you call them, the numbers aren't listed. Right? They're not in service. So that's a problem. So you can look down here. There's 94,184 numbers that were selected. All right. from this random digit dialing, for example. All right, and they need 1987, or they need some interviews from that. So how did they come up with 1987 completed interviews? Well, out of those 94,184, 12,985, they weren't in service. 25,471 were ineligible. All right, because maybe in your sample you need a certain age group to be in your sample, and there was nobody in that household who was in that age group. Here's another one, 27,931 of these 94,000 refused to even give you the information. Said, no, I'm not doing it. Hangs up on you, right? 8,597 of them were abandoned because of no answer. In other words, they didn't get an answer, and then they had some callbacks, because typically you try to call back if nobody answers. So if you add these numbers up, that's about 60, looks like about over 70,000 of these 94,000. You couldn't even interview at all. And then there were others probably that began the interview and for some reason had to leave the interview, so they weren't completed. And what you were left with, 1,987 completed interviews. So out of the 94,184 that were originally chosen through simple random sampling, you could only complete 1,987. So here's the problem. That's a small percentage of the simple random sample that you came up with, the initial pool of random numbers. The probabilities get all messed up when you only can interview a small fraction of the people that you want to interview. And so this becomes a very complicated subject. There are people who've written books about this. The math behind it is very complicated because you have to adjust your probabilities for the fact that most people weren't interviewed. So it gets to be very complicated. And who are the types of people who work in this type of field? People who are very good in mathematics. I'm telling you, that's a requirement. Like the Census Bureau in Washington, D.C., when they interview people, they're looking for math majors. And they're looking for people who got A's all the way through in math. So if you happen to know anybody's like that, like kids or something, that's a really good field to get into, because they're always looking for people to get into this type of field. So, but you need to be good in math. But anyway, this is complicated. But as far as you are concerned, as a person taking this course, you just need to know the types of sampling. That's it, basics, and be able to recognize it when you have a little situation that's described to you. You should be able to recognize one of these types of sampling. And sampling can get, as I said, very complicated. Sometimes what these sampling companies do is they combine sampling methods. In other words, they may stratify by region of the country. Then within the stratification, they may take another strata of communities. So they have a strata of regions. Then they have strata of communities. And then within each communities, they have city blocks, which they can say are clusters. So they take a sample of clusters, and then everybody within that block gets interviewed. Sounds very complicated, doesn't it? But that's what these sampling companies do. That's what the Census Bureau does. Again, good field to get into if you're very good in mathematics. And mathematics meaning good with numbers, good with understanding. You just pick up numbers in any type of math courses pretty quickly. If you know somebody like that, this is a great field to get into, because they're always looking for people. All right, now there's another type of sampling which is in this little section here, which I want to bring out to you, but let's just talk about difficulties in sampling. Now remember, when we talked about sampling last time, we talked about this idea of a sampling frame. Remember, we originally said that sometimes you don't have a list of everyone in the population. Like we don't have a list of everyone who lives in the United States. So what do we come up with? We have a list of households, all right? We might have a list of households. So that becomes what's called the sampling frame. The sampling frame is a list from which we can ultimately interview people. All right. Now, the sampling frame may not be the right group of households or people. It may include people that shouldn't be in the survey or shouldn't be in the population. All right. And it may exclude people that should be in the population. So sampling frame, it may be the only thing that we have, may be wrong. All right. Number two, we're not just like I showed you a minute ago, sometimes we're not able to reach everybody that's selected. All right. That example I just showed you a minute ago, most of the people that were in the original sample weren't even interviewed at all. We didn't even talk to them at all. And third, a low response rate. All right. In other words, suppose you do a mailer, you send a mailer out with a sample and ask people to return it. You could have a 5% response rate, 4% response rate. That's really low. All right. So most people just take the survey and what do? They put it into the circular file, right? What's the circular file? It's a trash can. So that's where, I mean, we all get junk mail and a lot of it just gets tossed, right? So you can picture sampling companies wasting a lot of paper doing this sort of thing. So that's a difficulty. What is it considered a disaster? Disaster would be a volunteer sample. Picture somebody at the mall, right? Somebody at the mall, and or even a better example. Suppose there's an advertisement to be part of a study, some sort of study. All right, and they're asking for volunteers. So everybody who volunteers probably has some motivation to be in that study. There's something about it that they might find exciting, but it may not, those people in the study may not be representative of the population. You might be leaving out people who are not excited enough to be a volunteer in the study. So volunteer samples, or what are called self-selected samples, are non-random. They may be biased in a certain way. So as a result, you're not going to be able to take your results of the sample, your study, and generalize it to the whole population. The same thing in what we call a convenience sample, or haphazard sample. What's a convenience sample? Be a case where you're at the mall. This is pre-pandemic, of course. You're at the mall and your job is to survey people. You're supposed to do it randomly, but let's say you have some quota, and there's a couple buses that come up to the mall entrance, letting a lot of people out, and you're looking at it and say, oh, there's the 50 or 100 people that I need, and then you interview all of them, the ones who are there somehow. Well, that's convenience, right? But what if all those people in those buses are not really representative of the whole population, but they represent a certain group, because that's why they went together. They're a church group or a synagogue group or something like that. Well, that is also a bias sample, non-random. And so that's another type of sampling that is not very good, because you can't generalize the results to the larger population. So then they show some examples here of having the wrong sampling frame. All right. So, for example, you're using a list of registered voters to predict election results. The problem is it includes those who are not likely to vote. All right. So what's the solution? You have to have some questions in your survey asking about their voting history. If they have no voting history and don't plan to vote, they have to be excluded, right? You don't interview them. Second one here, using a telephone directory to survey the general population. The problem is it excludes those who move often. They never get into the telephone directory, right? It includes people with unlisted home numbers, all right? Excuse me, it does not include people who have unlisted home numbers, right? Or those without a phone or in today's world, cell phones, right? So What's the solution? Random digit dialing. That's a way of getting around that. All right, so there are solutions to having the wrong sampling frame, but it's difficult. It makes it difficult. Not reaching the individual selected, right? Telephone surveys reach a disproportionate number of women because they are more likely to answer the phone. Now, this is old, right? The idea that women are at home and men work. Obviously, that's not true. But but the point of the matter is, you may be missing people who work when you do the survey, and you're talking to people who are at home. All right, so you're not going to necessarily get a population of the people that you want. Another type of polling that really is, you can't generalize the whole population of these quick polls, right? The ones you see on television sometimes, where they do a quick poll of people. These are very poorly conceived. They're definitely not random. And again, you can't generalize it to the larger population. Low response rates. This is a problem throughout the survey industry. Low response rates, because it really screws up the probabilities that, you want the probabilities to be equal. And when you have low response rates, it really messes that up. And also, do you really get a representative sample for the whole population? That's the problem when you have low response rates. All right. Volunteer self-selected sample, it's pretty obvious that it's meaningless if it's not random. It's meaningless. Volunteers are just a count of those who bother to take a TV poll. All right. So if you have one of these pop-up polls, TV polls, volunteer samples, it may not be representative of a population. Here's an example here. Do you support the president's economic plan? Well, if the TV station happens to be leaning left or leaning right, in political spectrum, you're going to get different answers, right? And if you did a random sample, you may get something completely different than a TV poll. All right. And again, convenience, haphazard samples. These are all examples of non-random samples. And once again, you cannot generalize it to the whole population. All right. Students in an introductory statistics class may be representative of all students at a university. Are they? Maybe not, right? We don't know. All right. So because you are taking a survey of just people in your class, doesn't mean it represents all students at Rowan University. And then they have this example, this famous example of the difference between non-random and random sampling. Here's the Literary Digest. This is back in 1936. There was Franklin Delano Roosevelt was the incumbent president, right? He had won in 1932. This was his try for a second term. He's running against this guy, governor of New York. His name was Alf Landon. He was a Republican back then. All right. Now there was a Literary Digest. It was a magazine that was available to people, typically the people who are more Republicans than Democrats back then. So questionnaires were sent to 10 million people from the magazine subscriber list. Remember, they were leaning more towards Republicans. All right. And many of these people who were subscribers to Literary Digest hated Franklin Delano Roosevelt. They were Republicans. They thought that he was just giving money away, blah, blah, blah. All right. Anyway, so out of those 10 million, 2.3 million, 23% response rate, actually responded. And they predicted, they loved Alf Landon, what he wanted to do, and they predicted he would win. All right, predicted a 3-2 victory for Alf Landon. There was this young man named George Gallup. Maybe you've heard of Gallup, but George Gallup was unknown. He founded this very small polling company called the American Institute of Public Opinion, and he was the one who began to develop random sampling in polling people. He was one who started doing this. And instead of having a couple million people in his sample, he only had 50,000. Now think about that, much smaller sample than that Literary Digest. And he did a random sample 50,000 from a list of registered voters, all right? And he predicted that Roosevelt would win. And his prediction was correct, and the Literary Digest was not correct. And that's how his career started. And the Literary Digest went out of business a couple of years later because nobody trusted them anymore. But the Literary Digest used non-random sampling, and George Gallup used random sampling, and he was more accurate with a much smaller sample than the Literary Digest used. All right. Any questions about chapter 4? So what I'm going to do now is begin chapter 5, which I will finish next time. But remember, for the quiz on Thursday, what I just covered is it. All right. What I will cover in chapter 5 will be next week's quiz, next Tuesday's quiz. All right, but not today.
How many questions again?
Typically 5, and there's statements within each of them, and either 2 or 4 fill in the blanks for each one of them. All right.
Okay, so not that long.
No, 20 minutes. Again, if you're familiar with everything that you've read, very quick. I've seen people get their quizzes done 5-10 minutes. Other people who probably didn't read anything, they're there to the last possible second. All right, so it really depends on how well you're prepared. All right, so this chapter deals with the difference between experiments and what are called observational studies. All right, so let's get started with this, and then we'll go as far as we can today and then stop and finish it up on Thursday. So again, we have these thought questions at the beginning of each of these chapters. So this one says here, in a study to relate 2 conditions, researchers often define one as the explanatory variable and the other as the outcome or response variable. All right. So in a study to determine whether surgery or chemotherapy results in higher survival rates for a certain type of cancer, whether the patient survived is one variable, and whether he or she received surgery or chemotherapy is the other. All right, so we have 2 variables. All right, the first variable says whether the patient survives, and the second variable is whether they receive surgery or chemotherapy. So can you tell me which is the explanatory variable and which is the response variable? Sort of common sense here. All right, everybody clear? There's 2 variables here. One of them is whether the person survives, and the other one is whether they receive surgery or chemotherapy. All right, so they're comparing surgery and chemotherapy as treatments, and they want to see, does the person survive after maybe a year, whatever they.
Is the response variable whether they received, the result of receiving chemotherapy?
And what is the, be more specific, what is the result of receiving chemotherapy?
Let me read this.
Because it says it right there.
Wait a minute, in the study. Higher survival rates.
Yeah, that's right. So the response variable is whether they survive or not after a certain amount of time. What is the explanatory variable?
It determines whether the surgery or chemotherapy results in higher survival rates. Wait a minute, I know it ain't all that. I'm sorry, I didn't read it, but it was just like self-explanatory.
Yeah. Can somebody help Anika out a little bit?
It's basically explaining what they're looking for. Whether the surgery or chemotherapy results in higher survival rates for a certain type of cancer, whether the patient survives is one variable,
That's
And whether
response.
he or
That's the response variable. You have to be
Oh.
clear about this. That's the
Oh, and
response
that
variable.
which is explained.
So what is the
Oh, all
explanatory
right. Well, I'm
variable?
gonna be quiet. I'm gonna be quiet.
That's all right. That's all right. Can somebody help Anika out? What is the explanatory variable in this case? Think about cause and effect. The effect is whether they survive. What's the cause?
Whether or not they get it or not,
Get what?
like radiation or chemotherapy.
That's it. That's it. So the explanatory variable is, did they get one possible treatment is surgery. The other possible treatment is chemotherapy. So the treatments are the explanatory variable. You have two choices here, right? Surgery, chemotherapy. And then the response variable is, did they survive as a result of one of those two? So you can picture that, right? Somebody determining whether after surgery, did they survive after a year? After chemotherapy, did they survive after a year? It's sort of like a yes/no type of thing, right? So the explanatory variable is the treatment, surgery versus chemotherapy. The response variable is, did they survive? That's it. Don't read anything more into it than that. That's all there is to this. It's cause and effect. Think about what's causing and what's being affected. And that's the way to figure it out. So in an experiment, researchers assign treatments to participants. In an observational study, they just observe what the participants actually do. Now, in the previous case, they could randomly assign patients to either surgery or chemotherapy, or they could just do a study and observe what happened when they actually got surgery or got chemotherapy. Now, if the researchers assign those treatments, that's an experiment. If a researcher is simply observing what happened when somebody got surgery or chemotherapy, but did not assign that as treatments, that's an observational study. You see the difference? In one study, the researchers are actually assigning the treatments, in the other, they're not. Okay. So for example, in the previous example, an experiment would not be feasible. Why? Because it wouldn't be right to say, all right, we're going to do surgery. You're going to be randomly assigned to the surgery group. Well, what if you don't want surgery, right? What if you're scared of that? You'd rather do the chemotherapy. There's no choice, right? You're not the choice is being made for you by an experimenter. That's unethical to do that. So this would be, that previous study was observational. It would have to be an observational study. And therefore you're not so in a sense, the experimenter's observing, but not controlling the explanatory variable. All right, here's another situation. You're interested in determining whether a daily dose of vitamin C helps prevent colds. So you recruit 20 volunteers, you want half to take vitamin C, the other half, you want half to take vitamin C and the other half to agree not to take it. So you ask each which they prefer, and 10 say they want to take vitamin C and the other 10 say not. Okay. So then you ask each to record how many colds he or she gets during the next 10 weeks. At the end of time, compare the results reported from the two groups. And so you're supposed to give 3 reasons why this is not a good experiment. So could give me one reason why this is not a good experiment.
Professor, real quick, what was the other word? What was the other variable? The name of it? It's explanatory and what?
Response.
Response. Got it. Okay.
How about this situation here? Anybody have any ideas why this is not a good experiment? Well, since nobody's responding, number one, you are asking for volunteers. Remember what we said in chapter 4. If we ask for volunteers, we cannot generalize the results to the larger population. That's number one. Number two, you're asking people which group they want to be assigned to, which treatment, the vitamin C or not the vitamin C.